Hi everyone, today we are talking about how to recognize functions from tables and graphs. As a reminder, you do not need to write down everything that we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you already got it. Just be careful, make sure you don't fast forward too much that you end up missing out on something important. So let's get started. You should probably remember that when we talked about functions at first, we said that sometimes they look like normal equations. However, a function is very particular. It is represented by an equation, but not all equations are actually going to be functions. A function needs to show a predictable relationship. And so what we mean by that is that there can only be one unique output that's assigned to each input. So you can't just have any random output come out whenever you put in an input. It has to be predictable. It has to be the same unique output each time. So not all equations are going to meet that criteria. Up until now, you have only worked with equations that have met that criteria. So this lesson is going to introduce you to equations and tables and graphs that don't meet that function criteria necessarily. So what we want you to think about is a soda machine. So think about how when you're buying soda from a soda machine, the input is the buttons that you press to tell the machine what kind of soda that you want, or water, or juice. And then the machine is going to process your order, that input, and give you, hopefully, what you asked for, the output. So before we move on, make sure you jot down this information. Okay, so we're going to think about a soda machine, and we want a predictable relationship. Only one unique output for each assigned to each input. So here are some examples of functions on a table. So in this first function on the left-hand side, we input -1, we get an output of 5. Input 0, we get an output of 3. Input 1, get an output of 4. Input 2, get an output of 7. Input 3, get an output of 4. This right here is a function, because each input has only one output. If I press -1 on my soda machine, I'll get a 5. There's only one possible answer. If I press a 0, I get a 3. If I press a 1, I get a 4. If I press a 2, I get a 7. If I press a 3, I get a 4. This one's kind of confusing because you see 2 4s in the output. So it's kind of there to trick you, but it is a function, because even though there's 2 outputs of 4, each input has only one unique output. So look at the table that's not a function to see what I'm talking about. Here, if I press 4, sometimes I get a 7, and sometimes when I press 4, I get a 14. That's not okay. That's unpredictable. I can't depend on this function to work, so it's not a function. I will have 2 different outputs whenever I press the same input. So it's the input that needs to be, or the output that needs to be consistent each time, okay? I can have 2 of the same inputs as long as their outputs are always the same. Here I have a 1 that gives me a 4. It's totally okay if I have another input that gives me a 4 as well. So this is why I want you to think about the soda machine. So if you have 2 buttons that'll give you the same output, it's just kind of like having a soda machine that has 2 of the same buttons. I have button 1 on the very top that'll give me a Sprite, and then I have the third button that also gives me a Sprite. That's not a bad thing. That means that the soda machine is actually kind of prepared for, one of the buttons to run out, right? If button 1 runs out, then you just go to button 3 and you'll also get a 4. So that's not bad. This, on the other hand, this is not a function, because if I press the 4th button, sometimes I'll get a Sprite, and sometimes when I press that 4th button, I'll get a Dr. Pepper or something. Okay, so it's the output that has to always be predictable. You can't have different outputs but the same input. That's not okay. That's not functioning. We say that that soda machine is out of order. So again, it's like pressing the same 4 button with unpredictable results. Sometimes you get a 7, sometimes you get a 14. Okay? So go ahead and pause the video and jot down some important stuff from the screen right now, so that you have this in your notes. You don't need to write down everything, but just make sure that you have the important stuff written down. So this is why we want you to think about the soda machine. So imagine if this is a soda machine that's functioning or a soda machine that's broken. All right, now from a graph, in order to see if it's a function or not, we use our pencil to perform what's called a vertical line test. So that's the same thing to see if you have one unique output for every input. So remember, the y-axis is your output. So that's why we are putting a pencil, we're sweeping it across our page vertically in order to see if the pencil only touches one point on the graph. So if it is a function, like this one right here, if you sweep your pencil vertically across, only one point on the graph should touch your pencil at all times. If it's not a function, when you sweep your pencil across the graph, more than one point could touch your pencil at the same time. Okay, so again, for this one, it is a function because it only has one output. This one right here is curved. We're not saying that all curved graphs are no good, but this one in particular, it curves in a way that my pencil is going to touch 2 different points. So this is the input, the x of -1. When I put in -1 for my input, sometimes I get a positive number for my output on the y-axis, and other times I get a negative number. So that's not okay. So remember, you're looking at your y-axis for your output. So if up and down you have the same x point, the same input, but different y's, then that's no good, okay? And you can practice this on your own at home with your pencil, sweeping it across the screen or across your paper. If you don't want to do that, you can always just draw vertical lines, and then you can also perform the vertical line test. So again, like I said, not all curved lines are bad. This one right here is a function because it's curving this way. When I draw vertical lines up and down, I only touch one point. But the curve sideways is not okay because when I draw lines up and down, it's going to touch more than one point at a time. And that means that you have more than one output for each input. Okay? So be sure that you have this stuff copied down before we move on to some examples. All right, let's take a look at this problem, see if we can identify if it's a function or not from a table. The table compares the initial amount of fuel that Li Jing's car had and the total distance she traveled using that amount in several different occasions. They're asking, can the total distance be represented as a function of fuel? So they're basically saying, is this a function or not? Okay. And then we can just mark these as x and y. Let's see. Yeah, so the input is going to be the amount of fuel, and that's going to, depending on how much fuel she has in her car, she can drive a certain amount of distance. So this is the input, the X, and this is the output, the Y. Go ahead and pause your video and try it on your own first. All right, so remember, I'm looking to see if each input has one unique output. So I'm going to scan through my X's and look for same X's. So I see 30 and 30. The 30 should only be lined up to one single output. Does it? Yes, it does. So these work. It's predictable. Every time I only have 30 liters of fuel in my car, I can go 100 kilometers. Every time. It's predictable. Okay, but that's only one of them. I also saw a 35 that was repeated. Does the input of 35 always give me an output of 120? Yes, it does. So it is also predictable. And those are the only numbers I see repeating. So it passes the function test. It is predictable because each input only has one unique output. So this should be a yes. Okay, so that's all we're saying. Is this relationship predictable? Let's try one more. All right, this one has words. Totally okay, same rules. The table compares the hats worn by each customer in a flower shop and the flowers that the customers bought. Can the type of flower be represented as a function of the type of hat? So it's a function of the type of hat. Function of X, the type of hat. So the type of hat is X, the input, and Y is the output. Go ahead and pause the video and try this one on your own. This is an interesting one. They're basically saying, can they predict the customer coming into the store, the hat they're wearing? Is that going to predict the types of flowers that they're going to buy? That's interesting. Like, see someone coming in with, a baseball cap. Does that mean they're always going to buy the same flower? Okay, let's see. I see a beret here and a beret here. Okay, it looks like if you come in with a beret, you're going to buy a daffodil. It's pretty predictable. Okay, that's predictable so far. What else? Let's see what else is, whatever this kind of hat is. Do they always buy violets? Oh, hey, they do. I don't even know what that is. And then that looks like that's it. So in this store, it's predictable. The type of hat that you're wearing is going to predict the type of flower that they're going to buy. So that's a yes as well. Okay. Now, if this table, let's say for this type of hat, ended up not being violets, it ended up being sunflowers, then that would make it not predictable, right? Because that would mean that one person came in wearing the hat, bought violets, the other person came in wearing the same hat, and they bought sunflowers. Then you would say, no, this is not predictable. It's not a function. The type of flower is not a function of the type of hat that you're wearing, okay? So that's what that would look like if it were not a function. Let's do some examples from tables. Now, I don't have a pencil on here that I can show you, so I'm going to be doing my vertical line test with lines up and down, okay? So remember, vertical goes up and down. Go ahead and pause the video and see if you can figure this one out yourself. Does the graph represent a function? All right, so again, if you have a pencil at home, you can take your pencil or pen or whatever, and you're gonna have it sweep across vertically. So meaning it's gonna go this way vertically. So it's gonna start off there and it's gonna end up here. Okay, so it's gonna go across vertically. If not, then you're just gonna draw some vertical lines, okay? So I'm gonna draw one here, I'm gonna draw one here, 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 and here. Does my vertical line touch more than one location? Yeah, it does. Here and here, here and here, like they all touch more than one location. So that means it's not a function. Why is that? Because, I'll show you, for example, on this point right here, if I put in -7 as my input, because remember x is my input, sometimes I will get, I'll just say that's a 7, even though it's a little bit off. Sometimes I'll get a 7 as an output, and other times when I put in that -7, I get a -7. Okay, so each time I put in these inputs, I get two possible answers. Two possible answers. That's no good. That's not predictable. I should have the same output each time. Okay? Let's do one more of those. So from a graph. So remember, you're using the vertical line test. Go ahead and pause your video and try this one on your own first. So remember, you're either doing the vertical pencil line test or you're just drawing some straight lines. So I don't have a pencil, I'm going to draw a straight line for each of these. Remember, I'm looking for just one unique output. So I have, it looks good. It's only touching the line at one point. So for example, let's use this one. It's a pretty point. When I put in 4 as my input, I'm only getting out 1 as my output. That's good. If it touched more than one point, then that would be bad. Okay, so this one should have been a yes. Let me know if you have questions as you work on these, but keep your soda machine analogy in mind. Is it predictable? When you press that button, are you always getting what you want? One answer. Let me know, like I said, if you have any questions, and I'll see you in class.